The other special right triangle that we're going to look at is the 30, 60, 90 triangle. And you get a 30, 60, 90 triangle when you cut an equilateral triangle in half. All right, so remember an equilateral triangle has equal sides and equal angles. All the angles are 60 degrees. And if we drop a perpendicular line from one vertex down to the opposite side, we'll get a right triangle, right? So we're just dropping an altitude straight down from one vertex to the opposite side. So that ends up cutting one of the angles in half, and the other angle will still be 60 degrees. And so we'll get the 30, 60, 90 triangle. All right, so now let's say we take an equilateral triangle where the side lengths are 2 units long. All right, so then if we drop that, if we cut it in half, right, that's going to cut the one of the sides in half, and so one of the legs will be 1, and then the other side we can figure out with the Pythagorean theorem. So if the hypotenuse is 2, the hypotenuse is one of the sides of the original equilateral triangle. We cut the other side in half. That's one of the legs, and then we can calculate the other leg with the Pythagorean theorem. So we find out that the other leg is square root of 3 units long. Okay, so that's the standard 30, 60, 90 triangle. So let's take a look at some examples using this 30, 60, 90 triangle. So, all right, so here's the 30, 60, 90 triangle, and we're given one side, and we want to find the other side length. So again, I'm going to start by just drawing that standard triangle for reference, okay? Because I want to set up my ratios, and it's good to see what the side lengths are of the standard 30, 60, 90 triangle. So the side lengths are 1, 2, square root 3. So that kind of makes it easy to remember. 1, 2, square root 3. But just remember that the hypotenuse is always the longest side. And so the longest side is the length of 2. So the hypotenuse is 2. The short side is 1. And the long side is square root 3. Okay, so you got to make sure you get the legs or the sides labeled properly. Okay. All right, so this is this let me write, this is the 60-degree angle, and then so this has to be the 30-degree angle up here. All right, so there's our standard triangle, and so let's go ahead and let's say we start by finding side A. All right, so I'm going to write A over the corresponding side of the standard triangle is 1, right? That's the short side of the 30, 60, 90. It's the side opposite the 30-degree angle. And that's equal to, now the side that we're given over here is the side length of 7. Now that's the long leg of the 30, 60, 90. It's the leg that's opposite the 60-degree angle. Okay, so the corresponding side over on the standard 30, 60, 90 is the square root of 3. Okay, so we're just setting up those ratios of the corresponding sides. So just make sure that if we're, here I put the A on top, the unknown side, the side that we're trying to solve for, the side length, so I'm using the triangle that was given in the problem. I'm putting that one on top. So make sure that the other ratio, again, is using this given triangle, this example triangle, and putting that corresponding side on top, and then the standard side length on the bottom. All right, just make sure you get those ratios in the right order. All right, so now let's do the algebra. There's not really any algebra to do. We just we're going to solve for A, but it's A over 1, so it's really already solved, right? So this is just going to be the 7 over the square root of 3. Now again, you could rationalize the denominator, right? Because we have the square root of 3. That's an irrational number. So if we want to rationalize the denominator, we would want to multiply by square root 3 over square root 3, right? Because that's just 1, so it doesn't change the value of the fraction, which creates an equivalent fraction. So if I do that, I'm going to get 7 times the square root of 3 on top. The square root of 3 times the square root of 3 is basically the square root of 3 squared. So then we're just going to have a 3 on the bottom. Okay, so that's the same. It's an equivalent fraction with a rational denominator. Okay. All right, now we're going to find side C. That's the hypotenuse, all right? So C over 2, okay, I'm just taking the corresponding sides, is equal to, we can do the 7 over the square root of 3 again, okay? And so now I'm going to solve for C. Now all I need to do is multiply both sides by 2. So I'm going to get C is equal to multiply both sides by 2, and I'm going to get 14 over the square root of 3. Okay, just like multiplying by 2 over 1. Now again, I can rationalize the denominator. It's multiplied by the square root 3 over square root 3. And then I'll get 14 square root 3 over 3. And that would be the answer with a rational denominator. Okay? All right, so the next one you could try on your own, and I'll record a video if you'd like to watch it. So I'll see you in the next video.